Today we're learning about similar polygons.
So similar figures have the same shape, but not necessarily the same size. You can abbreviate similar figures with the symbol. It looks like a squiggly line, just like that. The definition of a similar polygon says that two polygons are similar if and only if their corresponding angles are congruent and the corresponding side lengths are proportional. And remember, we went over what proportional is during yesterday's lesson. For the example, you can see that we have the angle indicators marked between angles, and you can see over here I labeled every congruent angle. So angle A is congruent with angle W, angle X and B are congruent. I know that because of these angle connectors, or the marks. Angle C and Y are congruent. And lastly, angle D and Z. So recall that when you're looking for congruent angles, you're looking to match the number of arcs that they have between the angles. Now these two figures are two different sizes, clearly, but they're proportional. So you can set up a proportion between the side lengths, and that's what I did right here. So we could say that segment AB right here, segment AB, is proportional to WX. And that's my first proportion. If all sides are proportional, then you can set up what we call an extended proportion, and we can continue to list the side. The reason why we can do it like this is because every side has the same multiplier. So next we would look at side BC, which is proportional to XY. Next we have CD, proportional to YZ. And lastly, we have AD, proportional to WZ. Okay, if I was to substitute in the values that I gave you on all of these figures, let's take a look at the first one. So let's look at AB and WX. The side length of AB is 15. The side length of WX is 5. If we were to simplify 15 over 5, it simplifies to 3 over 1. Next, let's look at BC over XY. BC has a side length of 12. XY has a side length of 4. 12 divided by 4 is 3 over 1. Length of CD is 21. Length of YZ is 7. 21 over 7 simplifies to 3 over 1. And lastly, AD is 18, WZ is 6. 18 over 6 simplifies to 3 over 1. So right here you can see that all of the simplified proportions are equal to the same ratio, which is exactly what you want. A couple of vocab words. The first one is called an extended proportion, and this is when you have 3 or more ratios. You can write an extended proportion just like we did up here. So this is an extended proportion. And a scale factor. So a scale factor is the ratio of corresponding linear measurements of two similar figures. And recall that when we went over scale factor a few lessons ago, we used the variable n to indicate that it was a scale factor. Okay, in this case, the scale factor between the smaller and the larger figure is 3. We found that out when we simplified all of our proportions. In the first example, we need to use a similarity statement to answer the following. So we have these two figures, but they're not oriented in the same way. So you can either redraw them if you want to, or you can just use the statement right here in order to answer the questions. So part A says, what are the pairs of congruent angles? And I'm actually going to use the similarity statement here to answer that, because I know that M corresponds with S, N corresponds with R, and P corresponds with T. So I can list all three of those. Angle M is congruent to angle S, and I'm going to mark it on my figure. Angle N is congruent to angle R. And lastly, angle P is congruent to angle T. Okay, what are the extended proportion for the ratios of the corresponding sides? So I'm going to also use my similarity statement for that as well. I know the first pair of corresponding sides is going to be MN and ST. So I'm going to set that up as a ratio, MN over ST. This is equal to the ratio of the next set of sides is also going to be a proportion. So I have NP over RT. And the last set is going to be the first and last letter of each triangle. So my proportion is going to be, or my ratio will be MP divided by ST. Be very careful. These are not congruent statements. These are proportions. So those sides are not equal to one another. They are proportional to one another. Think about when you enlarge the size of a photo. So if you keep the dimensions the same and you make it bigger, it's a proportional photo. For the next example, we need to determine if the polygons are similar. If they are, write a similarity statement and give the scale factor. So we don't know if these two figures are similar. We need to prove that they are or that they aren't. So the first thing that we need to do every time we're looking for this is prove that we have all congruent angles. Let's start with angle, let's look at angle D to angle R. We know those are congruent. We also know that F and T are congruent. Next, we see that C and Q are congruent. And E to S. After we prove that all angles are congruent, which we just did, so we're all set in that category, we now need to show that all sides are proportional. So I'm going to start with segment CD and QR. Next, I'm going to look at DE and RS. Next, we have EF and ST. And lastly, we're looking at CF and QT. I'm going to substitute in the side lengths of all of these figures. So CD and QR. CD has a side length of 3. QR has a side length of 4. DE and RS. DE is 6, RS is 8. EF and ST is 3 over 4. And lastly, we have CF and QT. CF is 6, QT is 8. If we simplify any of these ratios, we can't simplify 3 over 4, so that's going to remain the same. We can simplify 6 over 8. 2 goes into 6 3 times, 2 goes into 8 4 times. Can't simplify 3 over 4, and 6 over 8 simplifies to 3 over 4. So this here proves that all sides are proportional. We now know that these two figures are similar, so we can say that C, D, E, F is similar to, make sure you use the right symbol, Q, R, S, T. And the scale factor, it doesn't indicate the direction that you're going in. If you're going from the larger figure to the smaller figure, the scale factor would be 3 over 4. And if you're going from the smaller figure to the larger figure, the scale factor would be 4 over 3. So I'm just going to say the scale factor is 3 over 4. That's what we found. We found that right here. But just think about it logically. If the scale factor is 3 over 4, that means the figure would be getting smaller. It's 3/4 the size of the original figure, so obviously that would have to be from the largest figure scaling down to the smaller figure. Okay, this is our final answer. We can't say that's our final answer until we have all of this information. Number 2, we have triangle QRS and triangle TUV. So right away, you should see that we don't even know about the angles. So the first step would be to prove all corresponding angles are congruent. And we can't even do that. We can assume, but we can't prove it. So for number 2, we're going to say not enough information. And you have to recognize that right away. So if you follow the 2 steps I gave you, the 2 steps being up here, number 1, corresponding angles are congruent, and number 2, all sides are proportional. As soon as you look at number 1 for this problem, you would be able to indicate that there is not enough info to prove they are similar. And for the last example, we are going to use the similar figures to find the value of the variable. So based on this congruent statement, I know that segment AB is similar to segment AX, which is these symbols or these sides here. I also know that segment BC is congruent to XY. I said congruent again, sorry. BC is similar to XY. And the last one we are looking at is CD is similar to YZ. So in order to solve for the missing variables, we're going to have to set up a proportion. And my proportion, I'm going to start with my small figure in the numerator. You could do this either way, but this is what I'm going to do. The sides of the smaller figure divided by the larger figure. Okay, so let's start. Let's pick a variable. Let's pick x. So the side length of the smaller figure is going to be x. The side length of the larger figure is 7.5. Now, if this figure is similar, then you can use any other side length and set up a proportion, because remember, all sides are proportional. So the only other side length I can use is over here. I know the short side is 6. I know the large side is 9. Now I can cross multiply. And this is going to give me 9x is equal to 6 times 7.5, which is 45. Divide both sides by 9, and x is equal to 5. I'm going to follow the same process to solve for y. Y is the side length on the smaller figure, and it corresponds to 5 on the larger figure. So y over 5. And we're going to pick one other side. I'm going to use the same side that has our measurements for both lengths. So we know the short figure has a side length of 6 and the long figure has a side length of 9. So I can use 6 over 9 as my second ratio. When I cross multiply, 6 times 5 is 30 is equal to 9 times y. Divide both sides by 9, and your y value is 10 over 3. Leave that as a fraction. Do not convert that to a decimal. Now, if you want to check your work, you can substitute these values back into the figure, and you can find a ratio for all sides and make sure they come out to be the same. So what I'm saying right there is to do this part. Make sure that you get the same ratio for all of the sides. And that's how you would check your work. Okay, that's it for today's notes. Please let me know if you have any questions.